So now that we know the rules for the derivatives of the inverse sine or arc sine function, inverse cosine, inverse tangent function, we're going to throw these into the bucket, so to speak, and find some derivatives, okay? So let's start with this function g. Find its derivative if the function is x times arc sine of x. Notice that's the inverse sine function. And so what do I have to use here to find the derivative g prime? What rule of differentiation am I going to have to use? Certainly I'm going to use my newfound rule for the derivative of arc sine. But what else? Notice I have a product, x times arc sine of x. So I've got to use the product rule on this. Real important that you understand you cannot find the derivative by just taking the derivative of x, which is 1, times the derivative of arc sine of x, which is this up here, and multiplying those derivatives together. That will not work. Have to use the product rule. So it's the derivative of this function times arc sine plus x times the derivative of arc sine of x. Well, the derivative of x with respect to x is easy. That's just 1. What's the derivative of arc sine of x? That's the rule we developed in the last video. It's right here. It's 1 divided by the square root of 1 minus x squared. And so what do we get as our answer? 1 times arc sine of x is arc sine of x plus, right, what x times all this stuff is x divided by this stuff. And there is our derivative. Okay. Again, these are kind of strange functions, we get some weird results, but again, we're just using the rules step by step that we've developed. Let's look at number 2. What does it say? Find what? What's this? D over dr. This says what? Take the derivative with respect to r of what? This function. So what's in the parentheses, right? That is the function. And what rule do we have to use to find that? Well, it's a quotient rule. Right? I can't just take the derivative of the top and divide it by the derivative of the bottom. Remember, it's that quotient rule. So this derivative, right, we're asked to find this derivative, it's equal to what? We take by the quotient rule the derivative of the top function times the bottom function, which is the inverse tangent function, minus the top function times the derivative of the inverse tangent function, the bottom function, all over the bottom function, tangent inverse of r, all what? Squared. Okay. Now, what's the derivative of r squared plus 1? That's pretty easy. I hope everyone can get that immediately. It's just 2r. It's a simple polynomial, power rule, constant rule. And then what about the derivative of tangent inverse of r? What's what we developed in the last video? Just recall here it's with respect to x, but we're talking about r, so it's what? 1 divided by 1 plus r squared. Okay. By the way, when I write 1 plus r squared or 1 plus x squared here, is that the same as x squared plus 1? Sure. So it doesn't matter the way I write that denominator. And so that's important when I say here, this is 1 divided by 1 plus r squared. It's the same as what? 1 divided by r squared plus 1. What happens when I multiply r squared plus 1 times 1 over r squared plus 1? This product up here is now what? Equal to 1. It's just equal to 1. And so this simplifies down to 2r tangent inverse r minus 1 over tangent inverse r all squared. Got my dog barking in the background. I apologize. Must be having visitors. Okay. So there is another example, right? Using the quotient rule with one of our newfound rules. All right. Let's look at this one. Let's find dy dt if y is equal to cosine inverse t squared of t squared. So what are we using here to find the derivative? what rule here? Is this a product? Cosine inverse times t squared? No, it's cosine inverse of t squared. Right? You can't multiply by cosine inverse. You can multiply by cosine inverse of t squared, but it's just cosine inverse of t squared. This is a chain rule problem. Right? The outer function is the cosine inverse function. The inner function is t squared. So the inner function, u is t squared, and the outer, y equal cosine inverse of u. Okay. So what's the derivative of the outer function? That's what we have to do first. What's the derivative of the cosine inverse u function, right? Derivative of cosine inverse u would be what? Negative 1 over the square root of 1 minus u squared. So let's do that here. So dy dt is negative 1 divided by square root of 1 minus u squared. Now what is u? U squared. We don't want u in our problem, we want t. What is u equal to? T squared. So u is t squared, right? There's the inner function. Derivative of the outer function evaluated at the inner function times the derivative, right, of the inner function. Derivative with respect to t of t squared, what is that? That's just 2t. Okay. How do I square t squared? What do I do with these exponents? We multiply them, right? So this is t to the fourth. So let's simplify this down. I got 2t on top over square root of 1 minus t to the fourth, as we say. So we should make those simple simplifications, and that's it, right? We can't simplify this any further. Can't break up the square root of 1 minus t to the fourth. And then number 4, f of y is e to the arctangent of y. It's not arctany, it's arctangent of y. I'm not sure I know what the arctany function is, but it is arctangent of y. Okay, so what rule are we going to use here? Again, it's a chain rule. You see we have outer function is y equal what? E to the u. Inner function, u is arctangent of y. I'll put the in parentheses there. So arctangent of y. Okay, so how do we proceed? The derivative by the chain rule is what? The derivative of the outer function. What's the derivative of e to the u? It's just e to the u. E to the u, and u in this case is what? Arctangent of y. Times what? The derivative with respect to y in this case. Notice our y is our independent variable in this case, not our dependent variable, of arctangent of y. Okay. And what is this? What is this? By the rule we found for the derivative earlier of the inverse tangent function. This is the same as arctangent of x. It's 1 divided by 1 plus x squared. In this case, our independent variable is y, and so we get 1 divided by, I'll write it as y squared plus 1. You can do 1 plus y squared plus 1, doesn't matter the order of that. And what do we have? Then I have 1 over this times this, so this is on top. Over okay. All right. So, some strange looking functions that we get, derivatives that we get, but it's the way it's going to be for a while as we throw in these new rules and then mix them up with the rules we know, product rule, quotient rule, chain rule, and so on. Okay. So there are the rules for the inverse trig functions. So all we have left and what we're going to tackle in the next lecture are the logarithmic functions and the general exponential functions. We know the derivative of e to the x with respect to x is just e to the x. But what about the derivative of 2 to the x or 1/2 to the x? So we got to do the general exponential functions and then the logarithmic functions, the natural log function and the other ones. So we will work on those in the next lecture, and we will be done with all our basic functions and their derivatives.